question 3. So we need to show that that while the car is decelerating, its velocity is this. So first things first, the deceleration is 8 minus 0.6 t. So the acceleration is negative the deceleration. So we reverse the signs on this. So the acceleration is minus 8 plus 0.6 t, or rearranged it is this. Now v, we get the velocity when we integrate the acceleration with respect to t, so we integrate this, so we add 1 to the power, divide by the new power, giving us this. Of course we have an unknown constant c, however we are told when t is 0, v is 32.5, allowing us to realise that c is 32.5, so our velocity is this as required. Now for part 2, find the time taken to bring the car to rest. Well, at rest the velocity equals 0, so we need to solve our velocity quadratic equation equaling 0. So using the formula with a being 0.3, b minus 8, c 32.5, substituting it in, remember the formula is minus b plus or minus the square root of b squared minus 4ac all over 2a, and this gives us, well, two values in theory, but find the time taken to bring the car to rest. We want the shortest period of time, 5 seconds. Now for c, show that the distance travelled while the car is decelerating is 75 meters. Well, to get distance we need to integrate velocity, so we have to integrate our velocity. So here's our velocity, so integrating this we get this. Remember, we just add 1 to the power, divide by the new power. We're integrating from 0 to 5 seconds, okay, because we know it takes 5 seconds for it to come to rest, so that's the total time. So substituting in 5 we get this, and then taking away, substituting in 0, well, we get 3 lots of 0, so 0. So substituting the 5 in, we get these 3 terms gathered together, 75 meters, which is what we had to show.